Today's video will demonstrate how to identify redundancy in a class design problem and then reduce it. Hello, I'm James Helfrich. Redundancy is the bane of the existence of programmers, because if we have more than one copy of code, then fixing a bug one place will not fix it everywhere, and then the code falls out of sync. This video will demonstrate how to identify redundancy in a program and how to reduce it and even eliminate it. Inheritance redundancy is the extent to which common elements exist in an inheritance tree, and there are several different levels. For an example, distinct, which means there's no duplicate attributes or actions. Minor means any duplication of attributes or functionality is actually far apart in the inheritance tree. Critical, which means the siblings have common attributes or operations, and redundant, which means that there's lots of redundancy. Clearly, we don't want to have critical or redundant. So this is best explained by example. How can we reduce redundancy in a chess program? We're going to have a board that's going to have 64 pieces, and each piece is going to be a space, pawn, knight, bishop, rook, or whatever. So we're going to notice that each piece has a get possible moves method that need to be implemented. So let's focus on that. There might be some redundancy there. Let's take a look. Okay, we'll start by taking a look at our piece class. Now our piece class is going to have a pure virtual function called getMoves. It's going to take a moves as a parameter and a board. And when I go into each individual implementation, for an example, my king, I will implement getMoves, and it's going to go looking up left, up right, right, down right, and so on. And then we took a look at our queen, and it's going to do the same thing, except it's going to slide. And then we take a look at our rook, and it's going to do, the same thing. It's going to slide. This slide code looks identical. I think we have some critical redundancy. Let's see if we can fix that. Okay, so now I've done this work for the bishop and for the rook and for the queen. They all use get move slide. All the redundant code is missing. Excellent. Now, when I scroll down, however, I notice this move for a non-sliding piece, like a knight, looks a lot like the code that I had for the king that also had a non-sliding piece. This code looks almost well, it's identical. So what I need to do is also remove that redundancy by moving that functionality up into the base class. And I'll do that now. Okay, now that I've removed the redundant code between the king and the knight, now my last step is to make sure that there's nothing left. Let's see here. I have sliding and I have castling. That's unique to a king. Okay. The queen, there's nothing unique about the queen. She slides. The rook just slides. The knight is a non-slider. Got that covered. The bishop just slides. Okay. The pawn, well, pawn is different. Let's just put it that way. So none of this stuff is going to be in other code. So I think I'm finished. Let's run the program and let's see how it goes. Excellent. All my unit tests pass. You can learn more about this in the Designing Out Redundancy section of the Redundancy chapter of the Software Design textbook.